Machine learning works by training and firing artificial neural networks, just like what happens in our brains when we learn new skills or gain new knowledge. It is a budding field within the realms of artificial intelligence and computer science and is just starting to make its way into the realm of visual effects.
In this video, I will demonstrate a gradient descent algorithm implemented in Houdini with PDG. Understanding gradient descent is a necessary precursor to understanding machine learning algorithms because it is how most neural networks optimize and learn. In a Houdini PDG network, I start by wedging a number of attributes that control the scattering of these points. You can see these are fed in to these soft nodes to control the scattering and the distribution of the points. Then I import each of these points using a geometry import node. So each of these points is a work item. Then I create the x and y attributes on these points. These x and y attributes correspond to the x and y positions of each point. I then compartmentalize each point into one compartment using a partition by attribute node. Then, using these x and y attributes, I create a CSV file, which, as you can see here, creates a list of all the x and y attributes. Then, I create an attribute for the learning rate, which is the rate at which the algorithm that I'm going to explain in a moment will do its calculations. I then create an attribute for epochs, which is the iterations and the number of times that the algorithm will run through. And now, here's where it all happens. So this small bit of code is called a gradient descent algorithm. And basically what I'm doing is first I import the CSV file that we created. I create x and y lists for each attribute. Then I set the learning rate equal to the attribute that we created in this node, and the epochs equal to the attribute that we created in this node. Here is the gradient descent algorithm. So I take the equation of a line, as you might know as y equals mx plus b, or plus c in this case. So the linear equation of a line. I take the derivative of m and the derivative of c, and then plug that back in, multiply it by the learning rate, and then that gets our change in m and our change in c for each iteration. So our change in the weight and our change in the bias of this equation for each iteration. I then take these variables that have been updated and set them to attributes so that they can be fed into this add node to define the positions of points. Once I do that, and as I click through these work items, which is showing each epoch, so each iteration by jumps of 10, so you can see this happening in real time. And as we come to the thousandth iteration, you can see that we have a best fit line. And this is demonstrated in 3D space and is a demonstration of a gradient descent algorithm, a optimization algorithm that can be used to refine a machine learning network, a neural network. And this is just the precursor to many more things to come with proceduralism and machine learning.
In the future, machine learning will be used to vastly increase the speed at which artists can create art, giving artists more time to be creative and streamlining the tedious creation process. When combined with procedural tools such as Houdini, this will create an entirely new workflow paradigm for digital artists.